Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I'm Roberto, and we have,
Luciano.
and
Eugene?
thank you, everybody, for joining. If you never did Advent of Code is a code challenge that is published every day in the Christmas period on adventofcode.com. We are working toward the last year one that are 24 challenges that you can find on adventofcode.com. We are publishing also all the code in a GitHub repository, this one. And we have a YouTube channel where we publish all the recording. You can find the link in the description of the Twitch channel. Last time we recapped exercise 5 for year 2021, and this time we'll do exercise 6. All of this has a logic. We go from 5 to 6.
Yeah.
And probably
Very complicated logic.
Next time I can tell you that probably we'll do 7.
Mm.
But I'm not sure. Let's leave a little bit of magic in the air.
Yeah. Very surprising, Matt.
Yeah, surprise, we're doing 7.
Yeah. All right, so I'll go through exercise 6, which is Luciano's solution. So I'll try to explain that. We'll see how it goes.
I can help.
Perfect. So here we have the README. I suppose it's best to start with a description of the problem, and then we can look at the solution and then look at ways to improve it. So the first part is basically also the second part, but anyway, the story goes that the seafloor is getting steeper and we're going like super deep, and there are lanternfish, which are the ones which have like a dangling light in front of their eyes. And it turns out that each one of them creates a new one every 7 days. So they breed every 7 days. I'm not really sure why this is important for our submarine journey, but hey, good to know. This isn't a process that's synchronized between all of them. So this means that whenever we start our exercise, we're going to get a pool of lanternfish, each being due to breed on another day. So one of them might have 2 days left, another one might have 5 days left, another one might, have just bred and they're like up to 7 again. Another important thing to note is young ones, like the ones that have just been born, will take 9 days until they generate a new lanternfish. So there's even a little example here about how this goes. The game is about simulation, as you've probably guessed by now. So after 1 day, if we start with a lanternfish, which starts with 3 days, this means it has 3 days left until it spawns another. So after 1 day, its internal timer will drop down to 2. After another day, it will become 1. And after yet another day, it goes down to 0. After another day, it will reset to 6, which is the total number of days, because we're indexing at 0 in this example. And it will create a new lanternfish with an internal timer of 8. So this is the young first generation, not first generation, child lanternfish, I guess, which will take longer until it breeds again. So after another day, the first lanternfish, the one that just gave birth, is going to be down to 5 days, and the second one, which is the young lanternfish, will have decreased from 8 to 7. That's essentially it. There's a little explanation here of how this goes day by day. So you
By the
start.
way, maybe we can explain the input there, which is the previous code block. Or we can show the input.
It's no, maybe let's go through the small one, because the actual input to the puzzle is massive. So this is the input that we get. These are basically the days, comma separated, represent a fish, and the days left until it breeds, until it gives birth, until it creates a new fish. I don't know how to call it. So yeah, essentially we start with one that has 3 days left, one that has 4 days left, 3 days, 1 and 2 days left, basically. So we have this simulated here for 18 days. So this is our initial state, 3, 4, 3, 1, and 2 days until they breed. The second day, everyone dropped by one number, so 2, 3, 2, 0, and 1, after which we get a new one added to the end of it, which is the young fish, which was just given birth to by this one. This one reset to 6, and the new one starts at 8. And then this keeps on going, and new fish keep getting added whenever one of them ends at 0. And they just keep on breeding forever, basically. If you look at, I don't know if I can select a line. Can you select a column? Sorry, in VS Code?
Control Alt, try to Control Alt it and draw with the mouse.
Yeah, let's see.
You are on a Mac, sorry. On Mac is different.
Command Option, maybe?
I tried that. No, it doesn't work.
No.
Anyway, yeah, just...
There is a way to do a rectangular selection. I know that on a normal machine.
Yeah.
Normal, I mean not a Mac.
I know how to do that in Vim, but it doesn't help me much on this.
Well, there is the Vim shortcut mode for, I think.
I think it's Shift Option.
Shift Option. Let's see. Yeah, there you go. So if you follow a column all the way, Jesus, nice. Thanks for finding that out. So
I just figured it out.
Just to clarify,
combinations.
See, this one started at 3, then it went down to 2, to 1, to 0, back up to 6, and it added a brand new fish on the bottom, on the end of our fish list. Then it went down again, 5, 4, 3, 2, 1, 0. And once it reached 0, it reset and it added another new fish. Obviously, all the others do the same, so that's kind of the simulation that we have to do. Part 1 asks us to give the total number of fish after 80 days of simulation, and part 2 is 256 days, so more or less the same problem, just a larger scale. Did that kind of cover it, or did I miss something?
I think it's okay.
I
think
well,
it's clear enough to me, at least.
Hopefully you'll let me know in the chat in case I missed something or I wasn't super clear. Cool. So a quick look at the input, and then we can go see our solution. So the input is basically this massive old file. It's 600 fish we start with. A lot of them are near the beginning of their cycle.
300. You don't have to call.
Because you have... Correct. It has commas as well. Cool. So same as usual, we parse from the thing, and we start with a, we split the input by a comma, we map, we parse them as U8s. Yeah, exactly. Into a lanternfish sim struct, which we created. And I think we're going to start going through this right now. So the way this works is it has these two properties which are relevant for right now, the adult and young. Adults is basically an array, and the index in the array is going to be, the index in the array represents the number of days left before a fish becomes, before a fish gives birth, or whatever you call it when a fish reproduces. And the value in there is the number of fish which are in that state. So for adults, we start at 7 because we know it takes them 7 days to reproduce. And for the young, which are the brand new, just generated fishes, they start at 9 because we know it's going to take them 9 days. Mm-hmm. And day is a property which, for our simulation, represents how many days have passed. So it can iterate. It's basically, it implements an iterator. Yeah.
Quick comment, because here there could have been like a simpler implementation. Oh, yeah. Basically, one simple implementation could have been we literally keep a vector with all the fishes that are currently present in the pool, and every position is the timer of that fish. Like the value for every position is the timer of that fish, and then at every turn of the game, we just decrease all the values by 1, and everything that is 0 will generate a new fish at the end. The problem is that the growth of the fishes eventually goes fast, like it grows, I suppose, exponentially. So if you have to simulate a huge number of days, and by huge I mean already after like 80, I think it gets pretty big. That means that you need a huge amount of space, which is not going to fit in memory. And it also is going to be very, very slow to iterate through it every single time.
Even if it fits, for example, to give you a number about this in Python, this trivial implementation for 80 days take 11 minutes. 11 minutes to run for 80 days, so it's not doable.
Yeah.
So this is already an optimized solution where we are trying to limit the growth of the data set of the state by just counting how many fishes are in the same state, meaning that they will breed after a certain amount of days. And we also distinguish between adults and young, which may be something we can improve later, but you get the idea. We just count how many fishes are in the same situation rather than creating new fishes all the time.
We try to normalize our data. We try to represent the situation in the more concise way possible to avoid to waste resources. And obviously, if you have 2 megabytes of data and you have to work on them, is slower than having 1 kilobyte of data and working on 1 kilobyte of data.
100%. Yeah, also the fish don't differ in any way. Like all fish which have 3 days left are the exact same thing. So it makes perfect sense that we would just store the count of them rather than, represent them and simulate them individually. If they had some different behaviors, like if their neighbors mattered, like in Game of Life, or, if there was any once in a full moon, all the fish which have like 2, 3 or something days, but only 30% of them do a thing, then it'd be worth doing them separately. Cool. So yeah, you're right, both in terms of this is a much neater implementation than simulating all of them, and you're also right in terms of we can kind of blend the young and the adults into one thing, because once the young ones start at 9 days, but once they're done, they just reset at 7. There's nothing that starts at 9 except when a new fish is created.
Yeah, I think the reason why I went for this approach is because I'm not moving numbers around and just doing like a modulo thing. And this felt a little bit easier, but probably there are ways to use only one array. But we'll see it later when we look at the iteration logic.
Exactly. So let's move through the thing itself. So this is our just initializer for this, where we get a size of how many.
We get an array of fishes, basically. Well, an array of all the fishes you get at the beginning. You can consider they are adults.
Yeah.
So we use that as the only input. We don't have any young because they will start.
Can we jump a moment to the part 1? I don't remember the first line.
Of course.
Sure.
Okay, we collect into a lantern fish sim. So to do this collect, we implemented the trait from iterator.
Exactly, yeah.
Exactly.
So can we start from it instead of starting from...
Sure, you're right.
Probably it's better.
Okay, the implementation is right here. So from iterator of U8 for lantern fish sim. It's basically... Sorry?
Is T into iter item UA. Okay, I will never learn that syntax.
Yeah, so that basically means that you have you are basically producing something based off an iterator of items U8. So that will allow to collect from iterators of item U8, basically. And the iterator is what you get as an argument, so you can literally access the iterator.
Yeah. This is the iterator that we're being called with.
So in our case, the result of that split and map.
Yeah, exactly. The split and map will be this, and this is basically a representation of lanternfish sim. Or a way to make it work for here.
Now, to be honest, I think that this is not... Sorry, I was saying, to be honest, I don't think this is the most straightforward way to do this. I think I just wanted to use the from iterator because it's something I discovered recently enough when I was doing this exercise. Maybe it's better to just use a parse implementation as we have done in most of the other exercises. So you can just say input.parse and get back a simulation and put all the logic there. Because here in reality, we have some of the logic in the split, some of the logic in the from iterator. So, and also it's kind of repeated logic between the two parts. So maybe an optimization we can do later is just remove all this from iterator stuff and create a from string as we have done before.
So we do a lantern fish sim from a string and the string is our input.
Exactly.
Well, it'd be interesting to run a cargo bench as well before and after, see if there's any actual benefit. Anyway, for how this function works, it's fairly simple. It starts with a list of adults, and then for every fish that it gets there, it gets the number of days left of the fish, and it adds to the count for that fish. So, fairly fairly easy, and it returns a new instance of Lanternfish Sim with the list we just created. And yeah, I think it kind of makes sense.
Now we can jump to the new at this point.
Now we can go there. You're completely
if you control click, is jumping there, or VS Code is not that smart?
I don't know, man. Oh yeah, it does.
Perfect.
Sorry, I don't know VS Code very well. I should, because we've been streaming with this thing for a year, so I should know the editor I've been using for a year. Nah, apologies. One day I'll learn. I'm not a fast learner.
You can stream with VI if you want. We can't be useful because I tried VI 10,000 times. I always failed.
No, man, it's fine. I don't want to subject anyone to having to watch me use VI. Oh, sorry.
That might be a stream on its own.
Yeah, exactly. It's like watch programmers struggle to code. Actually, that's kind of what we do every day, but yeah. Not every day, every Monday, sorry. All right, so new is fairly simple. It just returns a new thing of the adults it got, which are the ones we just parsed earlier, an empty list of young, and day 0, because we started the first day. This also implements a function for counting the fish themselves, which just goes through the adults and the young and returns the length, basically.
Yeah, I was thinking we could do like a chain and count.
That's what I was thinking as well.
A chain and a sum.
And a sum, yeah.
Sum, yeah.
Or a fold, but writing the sum function. No, okay, sum is better.
Yeah. We could do that.
Last time with chain, we had very bad performances.
Well, the interesting thing is how Luciano implemented the actual simulation, which is as an iterator.
Part 1, to get to the 80 day, my God, sorry, to day 80, what you did? You did
We're calling nth of 79, so it does the iteration 79 times.
And so you get day 80 because we start with day 1. Okay.
Exactly. We start with day 0.
Okay, off by 1.
That's why 79. So yeah, we're off by 1 because, we got it.
Why not?
Yeah, so this is fairly simple. It does a modulo of the day you're currently on to figure out which
from which pool you are spawning, basically.
Yeah, which fish are gonna make new fish, basically, if that makes sense. And this creates a new young fish count. We do the same for the young fish, which, remember, they spawn new fish every 9 days instead of 7. So modulo 9, and then we get the new fish from the young fish, if that makes any sense. And then in adults, we add the young that have just bred, basically. And then to the adults, we add the ones that have just bred to the last.
Yeah, they basically became adults.
They just became adults, yeah. So they just reset their timer. And then we add the new young fish to the young list. We increment the day by 1, and we return nothing, basically.
Yeah, this is because an iterator needs to return an item. Here we are, again, this is maybe a little bit of a stretch. We are stretching the iterator trait just to be able to simulate days 1 by 1. We could have used another abstraction, but in reality,
you could have returned the current count of fishes, but it's overkill.
Yeah, because then you will count the number of fish every single day, which you don't care as well. You only care at the last day.
Yeah, but you could also just keep the count of fish, because you can put in the structure the total number of fish. You initialize that on the creation of the object of the simulation, and every time they breed, you add to that, and then the count is just returning a number.
Yeah,
that could be another optimization, and then here it makes sense at that point.
And then the iterator can return a number, and then the part 1 can become just iterator and done.
Perfect. Yeah, we can do that change at the end. I like it.
Yeah, fair enough. Okay, so
Bless you.
this is how it goes. Did somebody sneeze? Bless you. Ah, Roberto. Okay, cool. Sorry. I don't see because I'm only seeing the code right now. Apologies.
Sorry. I muted myself to not.
Roberto is allergic to my code.
Yeah, I'm allergic to Rust. Oh my god.
Fair enough. Okay, I guess that's all the code, right? Yeah, we went through how this works. We went through count fishes. We wrote a test, but I mean that's easy enough to understand. Right, so we can look at improvements. I would suggest
What
we
do now
start
is
by running.
running cargo bench, like you said.
Yep,
Remember
start
to go
with
in
a
the
cargo.
folder. Not go in the folder before that, because otherwise it's running cargo bench on everything, and I don't know if we have half an hour for that.
No, you're absolutely right. 6. This was exercise 6. All right, running a cargo bench. And what would you like to do after? Do we want to try parsing the input, or do we want to try making a single array of fish? Or
we can go with a single array of fishes. What is the plural of fishes?
I think it's
fishes.
fish.
Okay.
I think it's non-plural, but I don't know. I'm Googling it. Oh, the plural is either fish or fishes.
Cool, so we are both right.
Exactly. So yeah, there's no relevant stuff. Okay, cargo ran. Sorry, the freaking benchmark ran. Apologies. My brain is suffering from Monday. Cool. So we have a benchmark. This means we can start modifying. Roberto suggested we make these things into a single thing. So do we call it just fish?
Yeah, we keep a new size of 9 because it's the biggest one. And
yep.
When we
fish.
Oh well, we can yeah. Okay. And here we can sum at this point. Self-fish sum, or you can't.
Yeah, that's true.
Or you can't sum on top of an array.
No, you can. You probably need to do dot iter though.
Just a sec. Iter or into iter. Why is it unhappy with fish here?
Because it's array of 7, not of
yeah.
Must be array of 9.
Right, you are. Okay, this is gonna be fun now.
Oh, the logic, we can take a look at that later.
Let's do that later, yeah. New fish adults. What's adults? Oh, this has to be 9.
Yeah.
And
Can we
it
just
will
call
initialize everything to 0, and only the one from 0 to 6 will be.
That's probably good enough. Just rename adults to, I don't know.
I can't name it fish. Fishes.
Thankfully, you can use fishes, yeah.
And also for this, yeah.
What? We now know it's legal or correct or whatever. Okay, I think that was it. Do we want to call these fish or fishes?
Fish is good enough.
Okay.
For me.
Very
so let's
important.
review the logic.
So fish will spawn. New young fishes are going to be at whether it's 7 or 9. Oh yeah, the number. So let's just get these IDs back up again.
Yeah, your day will increment. That stay the same. Now the index will just be the one modulo 9, because now our array is just 9.
I think no. Isn't this essentially it? I'm not sure if this is going to work correctly. Oh yeah. Self-name.
Wait, do we need to consider the young IDX only if that value is between 8 and 9? Sorry, 7 and 8. in the
So
wait a
no,
moment.
we just need to take the ones at 0, basically, right?
Yeah, the one at start, the one at day modulo 9. That is the current one that will go to breed. All the ones that are at our day modulo 9 will breed.
No, why 9? Hang on.
Because the array is a 9, is long 9.
Yeah.
Okay.
But we wanted, so the day, because they breed every 7 days.
The one, yeah, but the one that breed will be the one at that pointer. Let's go there.
Okay.
We have an index. It's
yeah,
not
because
the young...
then when they are born again, we'll move them to the right position.
It's an index. It's not the young index. It's an
Yeah,
index.
yeah, yeah. You're right. You're
One,
right.
the fish that are giving birth, or whatever they do, are the one at that one. So the new fishes will be the one at that index. Cool. So now we
Okay.
know that. I don't think it must be mutable, but we'll see.
We
We know that we have to add that amount of fishes somewhere.
Yep.
Now we move the pointer to the generation later, but we don't care. Now we have to add that number to what? We have to take our current index plus 6, that are the one that are rolling.
Current in
Modulo 9.
Yeah. So IDX.
Put that in bracket because we have to do modulo 9. Okay.
Sorry. This is not supposed to be called that. Sorry. Say that again, Roberto.
That means self-fish.
Yeah.
Of square bracket, round bracket. IDX plus 6. Everything modulo 9. After the round bracket, modulo 9 to stay inside the array. This is plus equal the number of new fish.
New young fish, yeah.
If I'm not off by 1, like always with the the math, this must be enough because our pointer is moving through the days while the day go through. We know that today n new young fishes will born. We make them born in basically the right cell that is somewhere in the future.
Yeah.
And then we start to scroll. And I think...
But given that shouldn't we also move all the current fishes to -2?
No, because... first of all, try to run the tests.
Okay.
Just to see if I'm not telling bullshit.
I don't think it's going to work.
Because otherwise all the old fishes will breed in other 9 days, not in 7.
You're right.
Yeah, exactly. Like
sorry,
the
my math was...
old ones, new ones need to turn into old ones, so they can't stay at this index.
So I think before we breed the new ones, we need to shift all the current ones -2.
All the current ones meaning what?
All the ones that are about to breed.
Okay,
we shift them back by 2 days.
Okay, so the fish here...
Because their clock is like 9 at that point.
Yeah.
We are saying for the next round, make sure they breed again at 7.
Yeah. So essentially, you're saying the fish at the current ID, right? Move them at, self-fish IDX -2.
Modulo...
Yeah, everything must be modulo the length because otherwise...
Right. Modulo 9 is...
And here I have a question about modulo in Rust. Because if you do modulo of a negative number in Python, you always have a positive number.
Oh, that's something to test. I have no idea what happens.
What happens in Rust when you do the modulo of a negative number?
It's a good question. I don't know.
So these are just the fish. Hang on. So no, this doesn't. Sorry, I'm not fully getting it right now. So our indexes between 0 and 9 each represent a number of fish that have a number of days left until they breed. They breed at 0, and we're taking the current day, dividing it by 9, which is the case for the young fish. And
Okay, you're right. Yeah.
That's why I was a bit confused. Essentially,
No, you're right. Because okay, let's do this in a simpler way without the modulo. Then we can optimize later, and we see with cargo bench if it's working or not.
if it's doing anything, okay.
Okay, we stay always zero based. We remove the module in this way, and we shift the data for real.
Yeah,
Instead
we
of
can try
fishing
to
those
move
with-
them.
It is a small movement because it's not a lot of cells. So what we do is taking in the new young fishes self of fish of 0 because it's the one that will born, right?
So let new young fish. This is going to be the new fish that we create, and we go self fish.
Now we shift all the fishes by 1.
You can write that line and we'll write something in the middle.
Yeah.
You are basically assigning the new fish to position 9, right?
Yeah, exactly.
Which will be
new.
position 8, I think.
Yeah,
8, you're right.
because
And actually, I can just do this like so, because I don't actually need to.
You need
No,
to
you need it,
sum.
Yeah, we need it probably later. Keep it in a variable. It's also easier to read.
Okay, sure. It's not happy with
Because
this.
what is happening? Because we need it later. Now, what is happening is that we have to shift all the fishes
Does
from
it
1
know? No.
left. So let's do it a 4. For a variable I in 0 to 7. No, do with indexes.
Okay.
Yeah, do I comma fish.
Like a tuple.
Yeah, and
Yeah,
then we'll
in
do
fish self
fish
dot fish.
self dot fish dot iter dot enumerate.
Yep.
But we
Is
don't
it
need
happy?
that.
Yeah.
We don't need to keep the first one. We have to do that with one element less. But let's see if we can do this.
We can't always do it. Okay, so but now we need to shift them.
I was just thinking for I in 1 to 8 included, so to 9.
Oh yeah, that's fair. Let's do
Fish
it
of I minus 1 equal to fish of I.
Okay.
Fair enough.
1 dot 9.
I don't remember having used. Doesn't know how to do this.
Self
Okay.
fish of I minus 1 equals self fish of I. In this way, we shift all the fishes.
Yep.
The one that got 7 at that point, at 6, sorry, index 6, that is the 7th after the loop.
But we're going from 1 to 9 here. We're moving all of them lower, which means we shouldn't have added the young fish yet.
We have to add them later after the shift. Now we have to do two stuff. Put in 8 the new fishes. Perfect.
Yep.
Put and sum to the one in 6, so self fish of 6 plus equal what was in self fish of 0. That is new young fishes. New young fish.
Why
that
are we
is
putting...
what was...
the original breeders. Yeah, okay.
Yeah, because they jump back to 7, but also they inherit what was in index plus 1 them. I don't know how to...
I got you. I just put it in there. So essentially, we're adding the young fish at index 8, and this should be 5 then. No, 6 because it's 7 days. So these are the actual new young fish that we're putting in here because they will breed in 9 days. and these are their parents, which are going in at index 6 because they will breed in 7 days.
But we can't use selfish of 0 anymore because it got overwritten. So we have that in that variable there.
Is it a reference or is it a value?
It's an integer, so it's a value, I hope.
It doesn't complain, so...
Now,
I put a comment
like
here
this,
just to be clear.
Is it working? The test,
Let's see. Test part 1. Yes.
Okay. What
Wonderful.
cargo bench says?
Bench. Let's see.
Probably will be a little bit slower because of all the shifting.
Give it some seconds. Yeah, shifting might not be ideal.
It's still gonna be 9 shifting per.
Actually,
it's faster.
It's 17 seconds faster. That's not bad.
17% faster.
Let's see part 2.
Faster?
Part 2 is even more. That's nice.
Nice. Okay, good finding.
So let's commit status.
It's faster. Luciano.
Use single.
Probably the module operation is expensive.
It could be expensive, yeah.
It's always a division. Divisions are expensive from the CPU point of view. I was not expecting that. It's true that you are moving memory not in the heap but in the stack, right?
Because those also it's a small amount of movements and they are integers, so
they are integers, small amount of movements, and if Rust is smart enough, CPUs has instruction to do that in one instruction. If it's analyzed in the 4, understanding what we are doing. So I was not expecting to be faster, but it is.
It is. I committed, by the way, just so we have it there.
Benchmarks.
Okay,
now,
so
if we want to approach self-day at this point is not even needed anymore in this. If we want to do that with modulo, no, it's needed. But if we want to keep it like this, day is not needed anymore. But we leave it there. I want to try to do that with modulo later. I will do now the parsing that you were talking about, Eugen.
Or we can also do the count of fishes. Like rather than doing it on demand, we always aggregate up front.
Okay, so we can just return self fish.
I think some self fish.
Sorry.
No. I was suggesting that we store that in a variable in the state.
The count itself.
So every time we spawn new fishes, it will.
Sorry. Can we use usize?
I think so, yeah.
I think it fits. So.
And then this is something that we'll need to, in the new, what we can do is we count all the numbers in the fish array. If we sum all the number, do fish.eater.sum. Perfect. And now every time you do the breeding thing, we increase that by new young fish, basically.
New young fish, and we can return self.count. And I don't need to state.
You don't need to return.
Some self count or
self-count. So perfect.
Some self count.
Because this was an optional.
And now we have to change the return in line 23. It's not nothing anymore.
Cool. Let's see if it works and if it's any better.
And
now
also,
what you can do in the test, you can just return sim nth, because it's already going to be the value.
Which means we don't need the count anymore.
Remove the semicolon.
Which semicolon? Wait.
In that line you just changed.
There we go. Yeah.
And part 2 the same.
It's an option of usize.
You need to unwrap.
Okay, and I can also delete the count fishes thing because we don't need that anymore. Oh, it's unhappy. Because I need to change
part
this one.
2 needs to be changed.
You need to change part 2.
Cool, that's done. Can I just run all the tests? No.
Yeah, above line 58.
Oh yeah, wonderful.
We are testing. We are testing count fishes in the test.
But we removed it. So
Okay. Sorry. Days passing. Oh, this is also...
Just capture the next.
What do you mean capture the next?
So remove line. No, in line 78, just call it let num fishes equal that.
Mm-hmm.
And then replace count fish with yes, pretty much.
What's 5 is the count we expect?
Yeah.
Okay, yeah.
Okay, you'll need to
But then I need to
do it everywhere. Yeah.
Oof.
You can do a Control D magic.
You can't put sim
Command
next
D?
unwrap.
Wait, I'm just gonna do this the old-fashioned way.
Exactly.
Is this replace all? Yeah.
You fix line 78 because it double replaced.
No, I will do that later.
Line 78.
Just a sec, man. Let me do all the others. Snumfish. This is gonna be sim.
That will be sim.count, right?
Yeah, sim.count.
Right.
Actually, we could have used sim.count everywhere, by the way.
Yes.
But this way we are also testing that we return the right value. So
this feels dodgy, man. Just saying. Because there's a lot of let now. Oh, because we're not using it anymore. Yeah. Okay.
Yeah, we have to call the next, but we don't have to.
Okay, so we can also go cargo bench just to see if this did anything.
Those are just warnings. So
Yeah, it's because I'm defining a variable, but I'm doing precisely nothing with it.
Aren't we using it in the assertion?
Oh, it's worse.
No, I replaced it.
Yeah, the assertion's now using sim count.
So keeping the counter updated is getting worse performances than just sum everything at the end.
Yeah, because you have to iterate again, basically, right? Oh no, it's just adding a number to another number. What the fuck?
No, we are doing. I don't know why. We are doing more additions. It's true. We are doing for 80 or 256 times. We are doing that addition.
Yeah, but it's not.
But in the end, before we were calling count only once.
Yeah, I suppose we are doing more additions because in the previous implementation we were doing only 9 additions. Here we are doing as many additions as loops.
The loops.
Yeah.
Okay, so do we get rid of the count then?
At this point, yes.
So we can just return self-fish, iter, sum.
Yeah, but then you are still doing the sum every single time.
Yeah,
the fast way was the faster. It was faster because we were returning nothing.
No more count. Sorry.
It is also possible there is some overhead in returning.
I'll sort it just a second.
But you can't. You have a comment. Can't you just check out the file?
Oh, yeah, you're correct. Yeah. Sorry.
So you are sure that you are at the previous version. You check out the file.
Or just check out the file. Yeah, sure.
Yeah, I think it's enough. Git.
Yeah, it's fine. Git check out. What's the freaking file? Lib.
Source lib.
Oh fuck! I'm not in the right folder. Fine.
src/lib. Okay, now we are at the previews.
So if we do a bench,
it should be faster, like 7% or something.
Okay, because it's keeping the last run here through.
Yeah.
hoping that there is no noise on your machine.
There might be. I'm not running anything. No, 4%.
No.
Okay.
Oh, well, it's a little more. It's faster. In any case, it's faster,
Well,
even if it's not 7.
It was 7% slower, which means
Now it's
when it will
faster.
be faster, it will be by a smaller percentage.
Yeah.
Anyway, it doesn't matter.
Well, in any case, it's faster like this. Retarding nothing. Yeah, like Luciano was saying, probably retarding is adding some kind of overhead. Instead of retarding nothing, basically. Just the stop iterator is.
Okay, so let's try to implement a parse for it, maybe.
Mm-hmm.
Yeah. So impl from string, basically.
Mm-hmm.
Do we have this here? From str.
From str, yeah.
Yep.
Enter.
For lanternfish sim. It'd be cool if it gave me...
there is a way to do that.
Give me the boilerplate, but it doesn't. 5 implementations. Ah, no. That's for us. No.
It did import the from string trait.
Did, but sorry.
Oh, yeah. Click on the yellow bulb there. Light bulb.
Yeah, brilliant. Okay,
Perfect.
from string gets a string and it returns a self. Yeah, that sounds
You need to define the type of error, which can be empty. So just say equal parenthesis.
Mm-hmm. Okay, this is going to be input. Are we? We're going to be doing the split here, right?
Yeah, we'll do that.
And we can do the parse here as well. Okay.
And that's basically the starting fishes or something like that. That will be the iterator of the starting fishes.
An iterator, okay. Start fish, that sounds a bit weird, but okay, it's something. And this is going to give us each of the fish, and then we need to collect all of them into the correct kind of grouping, right?
Mm-hmm. Yes, which is something you can copy from line 50 to line 55.
Oh, yeah. And this, basically.
The only difference is that rather than being called either, it's called start fish.
Yep.
And this will be okay of all of that.
Ah, yeah, because it's potentially... Okay was all uppercase, right?
No, K is lowercase.
Never remember these things. Why is it
now?
unhappy?
Why is it unhappy? Good question. Why doesn't like that? It's not giving you the actual error, just giving you documentation of map. There you go. Mismatch. So we have a missing bracket or something.
Where?
Oh yeah, we are missing a parenthesis before the semicolon. Closing parenthesis.
Parenthesis, yeah.
Yeah, cool. Okay.
Also, we are parsing as U8, then we are casting to usides. Can't we just parse as usides?
Where do we cast as usides?
Line 46, we cast back to usides.
Oh yeah, you're right.
So
yeah,
let's
see
just
if
parse
we can
as
do
usides.
Can I do
just
it?
Change that U8 there
that
to usides.
To usides, okay.
And remove the cast in line 46, because in theory is not needed anymore.
Nope, sorry.
That one.
This might gain us some performance. Okay. How do I open that same...
Now you can delete all the from iterator because effectively we don't need it
I want to
anymore.
see it work first.
Yeah, but
then we need to replace
line
part
7.
1 and part 2, right?
Wait.
Yeah, line 65.
This thing, yeah.
You basically need to say input.parse.unwrap, and that's it.
Oh, yeah. Sorry. That seems nicer than the iterator. Okay, now let's run tests and see what we forgot. Okay, they all passed. Cool. Do you want to do a bench then?
Let's...
I don't expect to change a lot.
I'm surprised that you didn't get a warning that we are not using the from iterator, but I suppose also because it's a trait.
To remove it, yes, you are correct.
So that's probably why it doesn't complain.
Fair.
You forgot.
Wait.
No,
Is it still not in the fucking... Sorry.
Because you forgot a slash in the path.
Where are we? Okay. EX 2020. Oh, SRC.
Y11. No, what? Y11.
That's not a Y.
11. Okay.
Aha, now it's happy. Okay,
Slash
cool.
X, 06.
Sorry.
Okay, can go best from here.
Sorry, man. Ooh. Why?
We didn't remove that. The tests. The tests
we
are
are still
using
yeah. We need to use parse also in the tests.
Okay, no problem.
For that reason,
That's
was
why
not complaining
could
because
be,
somebody was still using the.
Even though I'm not sure if you implement a trait, if it will complain as unused code.
Probably not, because you can use that outside of this library.
If it's public, yes.
Yeah,
Okay.
if it's public, yes.
Let's see now. How did the tests... Okay, because we didn't delete it yet, yeah. Okay, so now it's doing it. Let's see what happens.
Ooh, much faster.
Nice.
Because creating the iterator is probably doing stuff, and then you just pass it through, and but we are creating the iterator inside the parse, but in a local scope instead of passing it around. You are not passing the iterator as parameter.
Yeah.
Also, it's not that big. I mean, it will be like few hundred fishes.
So it's interesting that it had
probably
more
it's just
effects.
passing the iterator around, because it basically when you then collect,
but it should be a reference. It's maybe that usides conversion that was.
That might be it. Do you want me to do that again? Come on, let's add the usize.
Yeah, please. Yeah, let's see how slow.
Was it a U8?
And then you need to do there as usides. Yeah.
Cool. How do I get back to the terminal now?
Command backquote. Command backtick. So yes, backquote, backtick. The one side of the one command and that one.
Fuck. Wait.
It does work.
Aha! Now, there you go. Sorry. Let's run the bench again and see if this makes... It should be significantly worse.
If it was that, yes.
Like 15-20%, right?
Something, yeah. It could be a bit less. Yeah. Oh, it's faster.
It's always getting faster no matter what.
Yeah.
Sorry.
I think it's the compiler itself learning how to just... Fucking why?
Okay, change it back again.
I'm very suspicious of this.
Maybe it's so fast that this is really noise. I don't know.
It could be.
We could use Valgrind, but I only know how to run it in an Ubuntu machine.
No.
Not in a Mac.
It's genuinely actually worse if you parse it as what it's supposed to be.
Interesting.
Run it again, please.
Yeah. I could start turning things off on my machine.
No, don't do that now. Stay. Don't move the mouse.
I think. I mean, yeah, why not? I suppose.
Yeah, the easy stable 0.4% is noise.
Yeah. Yeah. No, it is genuinely. Let me run it once more, and then I'll make it back to U8.
Is noise. 0 dot is noise.
If this one's similar, I'm turning it back to parse as U8 and then cast it as a size. And if that's quicker again...
Well, here is 2% faster, but again, 2% is not...
This could be noise.
And here is a little 0.7 slower, yeah.
Let's see. This is very curious.
Maybe parsing a sequence of U8 is something that can be vectorized. I don't know. I have no idea.
Yep, it's quicker.
It's quicker. Okay, quicker. Fine. I accept it.
So remember, kids, if you want to parse something, try to parse it as an unsigned.
As small as possible that fits.
Yeah.
And then casting it later if you need bigger numbers.
Well, of course, here it's safe to do that because we know every number is within 255, right?
Yeah, they're up to 6, basically.
Yeah,
up to
you
7.
could use 3 bits.
Yeah. So there's no need for anything so big. Okay, cool. So git commit. Amazing improvements by parsing as U8, not usize. We did something else because the
we
goal
did the
was
from string rather than from iterator.
Yeah, we get rid of the iterator from iterator. Instead,
Submitted.
you wrote
I'll learn how to spell at some point. Cool. Oh, and I need to set up. Actually, my Git is configured. It's probably just in this terminal. Okay. There was another thing we thought about doing, right? Or was this it?
We could try to fight with modulo operation and keep the day +1 that now is not used, but we still increment it. But
well, we have a cargo bench, so we can try that. We'll still need to shift something around.
I'm curious if we remove that self-day entirely, if we get faster.
Try. Comment it.
I mean, we should 13. Get faster, but how much?
On line 13, remove the variable.
Oh, yeah, right, you are. Can I just... no.
Well, you can remove it there and also in the struct.
Yep. Then I'm just going to delete this as well, because any more errors? No. Cool. Cargo bench.
Folder?
Yes, I am. I have learned the trick. Let's see. It's worse. Okay.
No, this must be noise of some kind.
Clearly has to be, man, because
it gets lazy if you let it do less work.
Yeah, this doesn't make sense that removing stuff would make it slower. Come on, do another.
But they are microseconds, come on.
Yeah. It is probably just noise, because there's a browser and Spotify and all sorts of crap running on my machine, so.
Bitcoin
also streaming
mining.
itself.
Oh yeah, streaming itself adds, yeah, you're right. Yeah, this time it's smaller, so yeah. I will put the day stuff back in.
Yeah, I was thinking how to do that with modulo to avoid the shift that we are doing there, but at the moment doesn't come fresh to my mind how to do
we
that.
still need to shift at some point. So we need to do a check for modulo 9 anyway. And if there are any fish at modulo 9, but then they could include other fish.
Yeah,
because you're just looking
to do that with the modulo, probably Luciano is right. You need 2 different arrays.
Yeah.
And
okay. I'm gonna remove
you need
the day.
an array of 7 plus 2 variables called new at 7 and new at 8 and new at 9, and then roll them, but go with the modulo on top of the adults. So yeah.
Just gonna run another test.
If I have time, I can submit a PR with that. If we keep this, are you fine with that, Luciano?
Mm-hmm.
Yeah, it would make sense. I'm running one last cargo bench. I removed the day altogether because we're not using it, so no point keeping it there. Okay, it's better now. This is definitely noise on my machine.
Yeah, for sure.
Cool. So, is there any diff? It's just
Do
removing.
we want to try something stupid next time?
Sure.
if we want, we could try to run it on bare metal. And by bare metal, I mean a Raspberry Pico.
Okay.
That might be interesting. Can you
That could
use
be
the
cool.
allocator, or do you have to make it like hipless?
I have no idea. It has 192K of memory. That is more than enough for this kind of problems. So it's not completely without memory, but I have no idea if you can.
Maybe you need to specify like an allocator.
Well, here we are not using a lot of heap, to be honest. We are using basically the stack because those are all arrays.
But vec itself.
But where do we use a vec?
Actually, yeah, we don't.
Isn't it? Oh no, it's not.
No, we just
an
use
array.
arrays. They are in the
You're
stack.
right.
That could be an interesting stream to try to run this exercise on a Raspberry Pico.
And can provide us through serial port, obviously, serial communication, can provide us through serial the output that can be the output of the tests, so we see if it's correct or not. And also we can try to see if we can run some kind of benchmark. At that point, we'll be in pure hardware, bare metal, no other processes other than the Rust one. And at that point, there is no noise in performances. It's a little bit overkill probably to just run the benchmark.
But it would be interesting to see if we can run that. Like if we need to do any code change to be able to run this on bare metal. That's what I'm curious about.
Would be very
also
cool.
all the tooling to ship Rust code compiled for Raspberry Pico. That would be interesting to see. Like, how do we compile? How do we publish it? How do we run it?
For now, the only stuff that I did in Rust on the Raspberry Pico was making a LED blink. That was my achievement.
Still something.
You know more than me for sure.
Yeah, I don't even have one, so I have an older Raspberry Pi, but like not a Pico.
Yeah, but with Raspberry Pi, you go again in this scenario with other processes stealing your CPU or stuff like that because it's a Linux system in the end.
Yeah. It's got Pydeon whatever on it. Yeah.
Armian or whatever. Okay, do we want to wrap up here?
Yeah, I think we should wrap it up.
Yes, yeah.
Cool. I'll stop sharing then.
You can find the recording on YouTube. The link is on the Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday at 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description. Give us a follow, whatever, thumbs up, thumbs down. Now they don't even show them anymore, so it's fine. Subscribe, send us money, everything. Do whatever you want. Feel free to leave comment, sending us PR. The repository is always this one. Everything is well accepted. We are trying to learn Rust. We have more questions than answers. We don't, but don't expect our solution to be the cleanest one or the most idiomatic one. We are getting better, to be honest, from the last year. If you know something, if you know how to do something in a better way, please tell us. Thank you for following us along. Are we going to ride somebody?
Yes, we are. So I'm gonna start the raid. See you next time. Bye.
Bye.
Bye-bye.